All right, our first question, we've been given the velocity of a particle, v of t, and I want to find the acceleration at t equals 5. So I'm trying to find a of 5. Well, that's just the derivative of the velocity at 5. Now here, I'm allowed to use my calculator, and I can find derivative at a point very easily. So the first thing I need to do is put in my equation to y equal y1. So 2 plus 5 cosine of pi x over 6. The t, I'm just taking my x variable. And then now, to take the derivative, I go to math. You'll see the derivative right here, 8. I'm taking the derivative with respect to x. The derivative that I'm taking is this function, which I've already stored in y1. And I bring y1 down with alpha trace. Now I have y1. And I'm evaluating it at x equals 5. So then now I put my answer to 3 decimal places. Doesn't matter if you just write the first 3 or if you round, but if you round, you better round correctly. So I find it easiest to just write literally the first 3 numbers. So then that is the acceleration at t equals 5. To know if the particle's speed is increasing, decreasing, or neither, I need to compare both v of 5 and a of 5. So the velocity and the acceleration at that time. A of 5 I already know is negative. V of 5 would just be plugging in x equals 5, but instead of writing the equation over and over, I can just say, okay, this equation at x equals 5. So y1 of 5, that gives me negative 10.99, which means this velocity is negative. Since both of them are negative, that means the particle's speed is both negative, increasing at t equals 5. Because v of 5 and a of 5 are the same sign. Finding all times in the interval where the particle changes direction. So particle changes directions when v equals 0 and changes sign. So I need to find this velocity and set it equal to 0. I want to find every time where it's equal to 0. So you can do it by hand, but it's way easier to do it in your calculator. Just go to your graph. So I'm going to graph the function, and I'm going to graph 0 on the y2, because then it'll be really easy to see when those two are equal, when they intersect. And then careful with your window. I want only times 0 to 0 to 10, so x 0 to 10. I'm going to graph. This is my graph. And then to find exactly where they intersect, I'm going to hit second trace, go to intersect, enter, enter, enter. So this one was already over to the right, so my second time is at t equals 8.744. And the reason that I know this at this time the particle is changing directions is because the velocity is 0 and is changing signs. Specifically, the velocity is changing from negative to positive. So at this time, because v changes from negative to positive, and then there's a second time, so I'm still doing second trace intersect. But now I need to move my cursor, so use the arrow to move your cursor over to that area. And now I can hit enter, enter, enter. And that time is at 3.255. And at that time, again, you have to have, I'm asking for these times, so I need it correct to the 3rd decimal place. And we chose that time because v changed from positive to negative. So if it says justify your answer, you are not getting full credit unless you write the because statement. And those justifications are super specific. If you want to tell me speed is increasing or decreasing, you need to talk about v at that time and a at that time, same or opposite signs. If you want to say that some particle is changing directions, you need to talk about velocity changing signs. And don't say it changes signs, you have to say velocity or v. Alright, no more calculator. Here we've got a curve. We want to write the equation of the line tangent. So equation of the tangent line, I've got my point already. All I need to do is find what my slope is. So the slope is just the derivative. So I'm going to take the derivative. I'm doing this derivative with respect to x. So 2y dy dx. This one is product rule. So negative 2y minus 2x dy dx. Derivative of this is negative 1. And if you're wondering, why are we not saying dx dx? Well, you can, but then dx divided by dx is just the same thing, so it cancels and it's just 1. Alright, I'm going to move these over. So 2y dy dx minus 2x dy dx equals 1 plus 2y. And then we factor out the dy dx and divide the 2y minus 2x over. Here's my derivative. This one, I cannot cross off the 2's because it's not in every single term. It's in 3 of the 4, but it's not in all of them, so I can't cancel it out. There's no way to simplify this. But I'm not asking for the derivative. I'm asking for the derivative at this point. So now we just substitute in 1 comma 3, which would be like your x and your y. So this is 1 plus 2 times 3 over 2 times 3 minus 2 times 1. This is 1 plus 6, which is 7. 6 minus 2, which is 4. And then that's your slope, 7/4. B is asking for the second derivative of the curve. So I found the first derivative, dy dx. To find the second derivative, you just take the derivative of that. So we're going to use quotient rule. So low, d high, derivative 1 goes away, derivative of 2y would be 2 dy dx, minus low d high minus high. D low would be 2 dy dx minus 2 times 1. Underneath the low squared goes. And then now we're ready to substitute. So we've got 2 times 3 minus 2 times 1 times 2 times. Now dy dx, you could take this and substitute it in, but I know I'm plugging in at x equals 1 and y equals 3. So see how I've already found what this is when x is 1 and y is 3? I've already substituted in that 7/4. And the only reason I can do that is because I'm still talking about the same point, right? If I change the points, then don't use 7/4. But I'm talking about that, so it's cool. Minus 1 plus 2 times 3 times 2 times 7/4 minus 2, all over 2 times 3 minus 2 times 1 squared. 2 times 3 is 6. 6 minus 2 is 4. 4 squared is 16. 16 on the bottom. This is 6 minus 2, which is 4. So I've got 4 times 2 times 7/4 for this whole term. The 4/4 cancels. 2 times 7 is 14. Right? This is 2 times 3 is 6. 6 plus 1 is 7. So then I've got minus 7. 2 times 7 is over 4. So 2 times 7/4 would just become 7/2. Because that's 14/4, which is 7 halves. So I have 7 halves minus 2 right here. I'm going to need to make a common denominator. So that's 7 halves minus 4 halves, which is 3 halves. So then this entire thing becomes 3 halves. Now I'm going to kind of move up. So I have 14 minus 21/2/16, because 7 times 3/2 is 21/2. And then because I have a fraction within a fraction, that's not nice. So let's multiply top and bottom by 2. So the bottom is now 32. The top, so this cancels, which is just minus 21, but then you need to make sure you multiply every term. So this would be 28. And 28 minus 21 is 7/32. And there's your answer. That was the kind of nasty one, sorry. Number 2, there's a funnel. At height h, the radius is given by this function. It contains liquid that's draining. At the instant when the radius is, this is a typo, that's supposed to be height. When the height equals 1, so h equals 1, the radius is decreasing at a rate of 1/2. So the rate of the radius, dr dt, is decreasing, so that's a negative rate, and 1/2. What is the rate of change of the height? So dh dt equals question mark. Now, I gave you guys an equation for r, so I'm just going to take the derivative with respect to time. So, dr dt. This one I'm going to use chain rules, bring the 2 down. So this is 2/5. 3 minus h, now to the power of 1. And then derivative of the inside would be derivative of negative dh dt. Now we plug in, dr dt is negative 1/2. 3 minus 1 is 2, so this is 4/5. And then there's a negative dh dt. So I'm going to multiply the 5 up, and then divide the negative 4 over. Negatives cancel. 5/2 divided by 4 again is the same as 5 divided by 8. Then that's your answer. This one, normally there's usually like, it might give me r and I use that to find h or something, but this one actually gave me everything, so I didn't have to go off and use the original equation to get any missing. 3a, so here I gave you the equation that in the part is saying just show that this derivative is actually equal to this, so you know what your end answer should be. So we're going to take our derivative, so that's 2x plus 6y plus 6x dy dx, because you use product rule there, plus 2y dy dx equals 0, derivative of the number would be 0. Now I'm going to subtract these two over. So this one I definitely need to be careful with showing my work because it gave me the answer, right? You're not getting points for getting the answer, you're getting points for showing that process. So subtract 2x minus 6y, pull out a dy dx, and that would be over the 6x plus 2y. And then I'm going to pull out the x, so that's 2x plus, or sorry, pull out the negative. And then because all of these have a factor of 2 in it, I can simplify this to negative x plus 3y over 3x plus y. And then I've shown my dy dx, and that is exactly what it's supposed to look like, so check, I've proven that. B, find all coordinates where the line tangent to the curve is horizontal, so that is the slope for dy dx equaling 0. So I'm going to take my numerator, the x plus 3y, set it equal to 0. Now I'm obviously not going to get a value just from this equation, so I'm going to just have to get a relationship. I find it easiest to get x by itself here, so x equals negative 3y. Take this, substitute it in for x. So that would become negative 3y squared plus 6 times negative 3y, y plus y squared equals negative 8. When you square this, this is positive 9y squared minus 18, y times y is y squared plus y squared equals negative 8. These are all like terms, they're all y squared, so this is negative 9 plus 1 is negative 8y squared. Divide the negative 8 over, you get positive 1, take the square root, y is equal to plus 1 and negative 1, because when we take the square root, both of those work. So I've got at least 2 points, where y is 1 and where y is negative 1. So here, to find the x value, it's easiest to just take this relationship, right? If x is equal to negative 3y, then when y is 1, it's negative 3, and when y is negative 1, it's positive 3. And those are your 2 coordinates. It doesn't have to be multiple coordinates. Oftentimes, you'll get like 2, or if it's like a quadratic little factor, you get 2 values for one of them, but it doesn't have to be. I've seen it be 1, I've seen it be 4 coordinates, etc. Now, where the curve is horizontal, so that is where dy dx is undefined. So that would be like dividing by 0. So I'm going to set the denominator equal to 0. Solve for y, so that's easiest here. You can solve for x, you're just going to have to deal with fractions. Now you're going to take this y and substitute it in, or y, obviously. This is negative 17 plus 9 would be negative 8x squared equals negative 8. Divide the negative 8 over. X is equal to both plus and minus 1. To find the y value, you just substitute in, so y equals negative 3 times the x. And then here are my 2 coordinates. In this case, it just happens that they are like the same but opposite. It does not have to happen. It just happened to work nice numbers here. All right, number 4, so we're given the graph of velocity. I want to know when the particle is moving to the left. So left tells me that the velocity is negative. So the velocity is negative. That's the graph is negative from 3 to 10. So your answer is from time 3 to 10 because the velocity is negative there. Is the speed increasing or decreasing? So you need to know the sign of A of 9 and V of 9. So V of 9 is just a graph. You go to the graph is negative value there. And then A is the slope of the graph, and see how that is a positive slope? That's a positive acceleration. So because these are opposite signs, so because A of 9 and V of 9 are opposite signs, that means the speed is decreasing at t equals 9. Positive acceleration. So acceleration is v prime, which is the slope of v. So the slope of v is positive when positive slope in here. So that is from 7 to 10. Because v has a positive slope, you could say the velocity is increasing. That means positive slope. You would not say the slope is increasing because the slope is positive, right? It's not saying the slope is increasing. The graph increasing means a positive slope. Those are not the same thing as slope increasing. And the time particle change directions, the velocity is equal to 0, and v changes signs. So then v is changing signs at t equals 3 because v is going from positive to negative.